Hello friends, now yesterday we have seen the functional dependency, one of the example and formula how to find out the functional dependency. Now this is again one example asked in GATE 2002. We are going to solve this example, but before that understand what is the functional dependency actually. Understand we can read this as A functionally determines B or A determines C. Now in this, let's take Aadhaar card UID. Now UID is a primary key which can determine the many things, like it can determine the name, it can determine address, it can determine the date of birth, etc, etc. So now this is what the relation. Now candidate key also can determine something, or any other key also can determine other key, because in relation there will be always some dependencies. So functional dependency in relational database, let's say the ABC is one of the relation R ABC, it will have some functional dependencies. Let's say determines B, B determines C, C determines A, etc, etc. So now we will understand what is trivial and what is non-trivial dependency later. Now understand this example, how to solve this example asked in GATE 2002. Very simple, but we should have the basic knowledge about the functional dependency, the formula I have given. Now in this example, we will start with the option A. Option A says that A determines B and B determines C. So we will check for whether A determines B or not. So understand first, are they matching here? Now we have the four tuples T1, T2, T3 and T4. Now we will check for T1 and T2. We will check the same values of the tuples. It can be T1, T4, it can be T3, T4, it can be T1, T2. Now in this case we can get it T1, T2. So the values are agrees here, they are matching here. So they must match here in B attribute. So we can see they are matching here. So that's why we can say that for T1, T2, A determine B. So this is correct. But again we have to check for the or another similar tuples, that is T3 and T4. Here you can say that T2, T2, T3 and T4 having two values same. They are agreeing here. So they must agree here. You can say they are having same values here. So in this case we can say that A determine B for T3 and T4 also. Now take the example of T2 and T3. The values are not same. So in the case values are not same, they are not agree here. They may or may not agree here. Still we can say that A determine B. So in this case A determine B, this functional dependency holds true. Now we will go for the B determines C functional dependency. Now check for the B column and check for the C column. So in this case, check for T1 and T2. So you can find here 1, 1 and they are agree here. So they must agree here, but you can say they are not agreeing here. So in this case, what is happening? We cannot say B determines C. So B determines C, it's wrong in this case. So the best is B does not determine C. So we will reject the A option. Then we will go for the B option. We will check here A determine B, that already we have verified, confirmed. Now we will check B determine C. This is also true. So this option seems true, but we need to check the another options. So we will check for B determines C. This is true, but this is partially true because A determine B is not given here. So we will also reject this option. And we will go for D option. In this option, they are saying that A does not determine B. So that is the wrong. That's why we will reject the option D. So correct option in this case is what? B. There are some characteristics of functional dependencies, so that we are going to see here on the board. You read the first. So functional dependency must hold on the table. It should not define on the it should define on the schema but not on the instance. So I will explain this, but not on the instance. So what is the instance? Let's say in T1 and T2 are matching. So some of the tuples may satisfy the functional dependency, but not all the tuples. So that is what it is on instance. Instance means on some particular tuples. So it should be defined on the table. It should functional dependency must hold true on the table or relation, and it should define on the schema. Okay, so the same thing. Now second is many times functional dependency defined is 1 to 1. Many times, majority of the times, but sometimes they are also defined 1 to many. Okay. Now third characteristic is that functional dependency must completely non-trivial. It should be non-trivial completely. It should not be trivial. So what is the non-trivial and trivial? So it's very important to understand, because many times this term will be used in the question. So understand, relation ABCD is there having the four attributes A, B, C, D. Now this relation contains some functional dependency. One of the functional dependency, let's say AB determines CD, and another will be ABC determines BC. Now understand, in this AB is the one of the attributes, set of attributes, or can be a candidate key, and it is a CD. Okay, now in this case there is no relationship between AB and CD. Means what? CD is not subset of AB, they are completely different. So in this case you can say that this functional dependency is non-trivial. Okay, and in this case ABC determines BC. Means what? It is the BC is a part, or it is a subset of ABC. So in this case you can say that this relationship as a trivial functional dependency. Okay, so I will take more examples. Hello friends, now again we are having some more examples for understanding trivial and non-trivial functional dependency. This is important topic. So relation ABCD, relation R is having attributes ABCD. Now first dependency you can see as a determine B. So this determines, now understand there is no relationship between the key. Means what? There is a no, B is not subset of self. So you can say that this A determine B dependency, functional dependency, this FD. So many times you can find an example functional dependency as a FD. So this FD is completely non-trivial. Again you can see the AB determines CD. So CD is not subset of AB or the first key. So this, in this case you can say that this is also completely non-trivial. Okay, completely non-trivial functional dependency. Now in this case, second example, now 1 2, now take this third example. Now we will see the fourth example. In third example, ABC, as we see earlier, determine BC. Means what? BC is a subset of ABC. So in this case this relationship is called as trivial functional dependency. Means in this functional dependency we are not getting some extra information that is already there, because ABC means what? You can directly determine. So that is what trivial functional dependency. Now fourth example we can have AB determines BD. So this is complex example. We will divide this example into two. This means that AB determines B according to the inference rules, and we will have AB determines D. So now AB determines B. This relationship is, you can say this relationship is what? Trivial functional dependency, and this functional dependency is what? Non-trivial. So we were seeing this example AB determines BD. Now we have divided into two. AB determines B, this is found as a trivial functional dependency, as well as AB determines D. This is completely non-trivial. This is complete non-trivial functional dependency. But AB determines BD is not completely non-trivial functional dependency, but it is non-trivial functional dependency, because one of the you can say the part, one of the division is non-trivial functional dependency. Okay, that's why we can say this as a non-trivial functional dependency. So we are going to see some more examples depending on this when we move for the, now we will next move for the keys, different keys, and then we will go for the we will move for the functional dependencies. We will move for the normalization in table. In that normalization we are going to use this functional dependencies technique. So now we are going to see the closure set of attributes. We are going to see the reduced like how to reduce the functional dependencies. Again we are going to canonical forms and different things we are going to learn in next videos. Again one thing is that in some of the questions you will be given only functional dependency as in relation, then you have to find out the closure set of attributes. You have to find out the different candidates, candidate key or primary key or super key. That questions asked many times. So thank you for watching this video. Please subscribe my YouTube channel if you like this video. I am trying my best to deliver this knowledge, especially which is helpful for NIC, Scientist B and Technical Assistant A post, as well as for NET aspirants, or for, as well as for GATE 2020 aspirants. So thank you very much.